The universe is expanding, accelerating, and yet, in its expansion, it hides a secret that torments the brightest minds. A paradox so fundamental that even the most elegant equations struggle to contain it. Cosmologists, armed with telescopes, supercomputers, and centuries of accumulated knowledge, lie awake at night, haunted not by what they see, but by what they cannot reconcile. It is the question of existence itself, framed in numbers, probabilities, and the laws of physics, yet slipping beyond certainty with every discovery. It is the realization that the universe is both knowable and unknowable, finite and infinite, deterministic and unpredictable, a riddle etched into the very fabric of reality. At the heart of this paradox is the tension between what we observe and what theory predicts. The cosmos is vast, composed of galaxies, stars, planets, and interstellar gas, yet the majority of its matter, roughly 95%, is invisible. Dark matter binds galaxies together. Dark energy drives their acceleration apart. We can measure its effects, trace its influence, and model its behavior, yet we cannot see it, touch it, or fully explain it. The universe, in its grandest strokes, obeys principles that we can describe mathematically, but the underlying truth eludes comprehension. Cosmologists call it the dark sector, and it is a domain where certainty fades into speculation, where profound questions loom larger than any answers. Consider the expansion itself. Observations show that galaxies are not merely receding from one another. They are accelerating, propelled by dark energy at a rate that defies intuition. It is as if the universe is stretching a cosmic canvas, pulling the fabric of space faster than light can traverse, and yet no visible force is acting, no engine driving the motion. Dark energy is invisible, pervasive, and poorly understood. Its very presence challenges our understanding of physics, suggesting that the rules we rely on, gravity, relativity, the behavior of matter, are incomplete, that the universe is stranger than any model we can construct. And this tension, between observation and theory, between prediction and reality, is what keeps cosmologists awake, peering into the void, staring at the equations that describe everything, yet explaining nothing. The paradox grows deeper when we consider the universe's beginnings. The Big Bang Theory, supported by observations of cosmic microwave background radiation and the expansion of space, tells us that the universe emerged from an incredibly hot, dense state approximately 13.8 billion years ago. Yet, when we look back in time, extrapolate physics to its extreme, and confront singularities, points where density and temperature become infinite, the equations break down. Time itself becomes meaningless, and our understanding evaporates. The very moment from which the universe arose is mathematically incomprehensible, a paradox encoded in the physics of creation. How can something emerge from nothing? How can time begin without a prior moment? These are not merely philosophical questions. They are scientific enigmas that defy resolution, provoking debates that stretch from theoretical physics to metaphysics. And the paradox does not end with beginnings. Observations of the universe's large-scale structure, the cosmic web of galaxies, clusters, and voids, suggest order arising from randomness. Quantum fluctuations in the earliest moments of cosmic inflation appear to have seeded the structure we see today, yet the mechanisms remain mysterious. How does order emerge from chaos? How do the tiniest variations in a near-uniform early universe blossom into clusters spanning billions of light years? Cosmologists wrestle with these questions, realizing that the universe is simultaneously elegant and inscrutable, deterministic yet probabilistic, observable yet unknowable. It is a landscape of contradictions, a paradox wrapped in reality, a cosmic puzzle that no single mind or model can fully contain. Even our most powerful instruments, capable of peering across billions of light years, offer only fragments of the truth. Telescopes detect light from distant galaxies, radio waves from cosmic phenomena, and the faint glow of ancient radiation. Yet these glimpses are filtered through time, distorted by gravity, and confined to narrow windows of perception. Each observation raises more questions. Why does dark energy have the strength it does? Why does matter dominate over antimatter? Why does the universe appear flat, uniform, and finely tuned for structure? Each answer is provisional, tentative, leaving cosmologists to wander in a landscape where certainty is fleeting and paradox reigns supreme. Some of the most profound conflicts emerge when theory predicts outcomes that reality does not confirm. Calculations of vacuum energy, for instance, suggest a density of space billions of times larger than what we observe. The equations scream for a universe crushed by its own energy, yet we exist in a cosmos barely perturbed by the vacuum's influence. How can theory and observation diverge so drastically? How can the universe be stable, structured, and capable of hosting life when the underlying physics seems poised for chaos? These questions are not idle curiosities. They are existential confrontations, revealing that the cosmos is stranger, more delicate, and more astonishing than any model can convey. And it is this tension between observation, theory, and the limits of understanding that keeps cosmologists awake at night. They lie in darkness, considering universes that may exist in parallel, contemplating dimensions we cannot perceive, calculating probabilities that defy intuition, and staring into a cosmos that offers answers only partially, fleetingly, and incompletely. The paradox is not merely a scientific problem. It is a reminder that the universe is vast, indifferent, and profoundly mysterious, that knowledge is provisional, and that wonder and terror often coexist in equal measure. Even as we contemplate these enigmas, it is humbling to recognize our place within them. Humans are fleeting observers in a universe governed by forces both comprehensible and inscrutable. Our instruments, our mathematics, and our theories allow us to glimpse fragments of truth, yet the deeper we probe, the more questions emerge. The paradox is a mirror, reflecting our limitations, our curiosity, and our persistent desire to understand the unfathomable. It reminds us that the universe is both a puzzle and a teacher, that existence itself is more complex than any model or metaphor, and that the search for knowledge is both noble and eternally incomplete. If the mystery of the universe stirs awe and curiosity in you, then 404 Altverse is your gateway. Subscribe and explore with us the enigmas that haunt the greatest minds, where science brushes against the infinite and paradox reigns as both obstacle and inspiration. The universe may be unknowable, yet in striving to understand it, we discover the deepest truths about ourselves. Even now, theoretical physicists grapple with competing models, multiverses that suggest infinite realities, quantum mechanics that blur cause and effect, and cosmological theories that stretch imagination to its limits. Each offers partial clarity while deepening the paradox, revealing that the cosmos is not only stranger than we imagine, it is stranger than we can imagine. The paradox, like the universe itself, is unyielding, persistent, and breathtaking in its scope. To understand why cosmologists lie awake at night, one must grasp the unsettling reality that the universe defies complete comprehension. The very laws of physics that describe planets, stars, and galaxies break down at extremes. At singularities inside black holes, matter is compressed into infinitesimal points, densities become infinite, and space-time curves beyond the reach of any equation. The Big Bang itself was such a singularity, the origin of everything, yet a point where time and space collapse into a mathematical paradox. Cosmologists are haunted by this. The universe began from a state we cannot describe, obeying laws we cannot fully understand, yet somehow resulting in the cosmos we see today. And yet, the universe is ordered. Galaxies rotate, clusters form, cosmic filaments stretch for billions of light years, and physical constants remain astonishingly fine-tuned. Slight variations in these constants could have produced a lifeless, chaotic cosmos, collapsing under gravity or dispersing matter into irrelevance. That our universe exists as it does, structured, observable, and capable of hosting life, adds a layer of profound mystery. Why this balance? Why this precision? And what does it imply about the fundamental nature of reality? Cosmologists call this the fine-tuning problem, and it sits uncomfortably alongside the paradoxes of dark energy, singularities, and the multiverse. Consider dark energy, the force accelerating cosmic expansion. Its measured value is staggeringly small compared to what quantum mechanics predicts. The equations suggest a vacuum energy billions of times stronger, a density that should have torn the universe apart instantaneously. Yet here we are, on a planet orbiting a modest star, observing galaxies slowly drift apart, pondering our existence. The disparity between prediction and observation is known as the cosmological constant problem, a fundamental paradox that remains unsolved, haunting theorists as they attempt to reconcile quantum mechanics with general relativity. Every calculation reminds us of the limits of human understanding, yet compels the mind to probe further. Then there is the question of entropy and the arrow of time. The universe moves from lower to higher entropy. Disorder increases relentlessly. Yet the initial conditions of the cosmos were remarkably ordered. Why did the universe begin in such a low-entropy state, allowing complexity, galaxies, stars, and ultimately life to emerge? The thermodynamic paradox is a silent specter in cosmology, a reminder that even the simplest observations, the flow of time, the emergence of structure, are underpinned by mysteries we cannot resolve. Cosmologists sleep uneasily because every answer seems to raise yet another question, as if the cosmos is teasing the limits of comprehension itself. Quantum mechanics adds another layer of unease. At microscopic scales, reality behaves probabilistically, governed by wave functions and uncertainty. Particles exist in superpositions, only collapsing into defined states when observed. Yet this indeterminacy appears to underlie the macroscopic universe. Cosmologists ask, is the cosmos itself a quantum system? Are the galaxies, the clusters, the filaments, somehow emergent from probabilistic laws? If so, then determinism, causality, and the linear flow of time are illusions, fragile constructs masking a reality that is fundamentally uncertain. The universe is orderly, yet fundamentally unknowable, a duality that makes even the most elegant equations feel like approximations of a deeper, hidden truth. And there is the multiverse. Some cosmologists propose that our universe is only one of an infinite ensemble, each with its own laws, constants, and histories. In this framework, the paradox of fine-tuning becomes a statistical inevitability. We exist because we inhabit a universe compatible with life. But the multiverse itself is largely unobservable, raising unsettling questions about the nature of reality, evidence, and truth. If other universes exist beyond our perception, then our understanding of existence is incomplete at a fundamental level. The paradox persists. Reality is vast, layered, and partially inaccessible, yet our consciousness strives to grasp it in totality. Even the concept of cosmic horizons contributes to the unease. Light travels at a finite speed, and the universe has a finite age. This means that vast regions of space are forever beyond our observational reach, hidden behind the cosmic horizon. Events there may influence nothing we can detect, yet they exist, evolving independently, adding an invisible complexity to a universe already staggering in scale. Cosmologists realize that what we observe is merely a patchwork of phenomena, fragments of a reality that extends infinitely beyond perception. In essence, the universe is partly unknowable, and yet we are compelled to understand it. And while these mysteries might seem abstract, they have tangible consequences. The paradoxes of dark energy, fine-tuning, entropy, and quantum uncertainty are not academic exercises. They shape our understanding of reality, the fate of the cosmos, and our place within it. Will the universe expand forever, tear apart, collapse into a big crunch, or evolve into something unimaginable? These questions are intimately tied to the paradoxes that challenge cosmologists, and their implications are staggering. The end of all things, the ultimate fate of matter, energy, and space itself, may hinge on principles we barely comprehend. If this profound tension between understanding and mystery resonates, then 404 Altverse is your portal. Subscribe and journey with us into the paradoxes that haunt the universe, where science meets philosophy and certainty dissolves into awe. In exploring these questions, we confront not only the cosmos but our own limitations, curiosity, and place in the grand narrative of existence. Even now, research pushes forward. High-precision measurements of the cosmic microwave background probe the universe's infancy. Gravitational wave observatories capture the echoes of collisions billions of light-years away, and particle accelerators attempt to reconcile quantum mechanics with general relativity. Each observation clarifies, yet simultaneously deepens the paradox, reminding us that the universe's mysteries are inexhaustible. The paradox that keeps cosmologists awake at night is not a single puzzle, but a tapestry of contradictions, stretching from the birth of the universe to its ultimate fate. Imagine the universe as a vast symphony, its instruments governed by physics, yet the conductor invisible, improvising beyond our perception. Every galaxy, every cluster, every photon obeys the laws we understand, yet the overarching harmony, the hidden logic, remains elusive. Cosmologists lie awake not merely because they lack answers, but because the questions themselves are boundless, infinite, and tantalizingly beyond reach. At the core lies the tension between the infinitesimal and the infinite. Quantum uncertainty rules the microscopic, dictating probabilities instead of certainties. Subatomic particles flicker in and out of existence, their states undefined until observed. Yet these quantum laws underlie the macroscopic universe, from stars and planets to galaxies and clusters. The paradox emerges. The cosmos appears ordered and deterministic on large scales, yet its foundation is probabilistic, uncertain, and fundamentally unknowable. How does predictability arise from randomness? How does certainty emerge from uncertainty? These questions haunt every equation, every model, every simulation. Dark energy intensifies the mystery. This invisible force, accelerating cosmic expansion, dominates the universe's fate yet remains inexplicable. Its measured value is staggeringly small compared to theoretical predictions, a discrepancy that could reshape our understanding of physics if resolved. Some speculate that dark energy is a property of the vacuum itself, while others propose exotic fields or interactions beyond known physics. Its presence drives the expansion, stretches the cosmic voids, and isolates galaxies, yet its origin and mechanism are mysteries that defy observation. Cosmologists wrestle with this enigma nightly, calculating outcomes, running simulations, and confronting a reality that seems simultaneously precise and unfathomable. And then comes the multiverse, a hypothesis both thrilling and disquieting. If our universe is one among infinite others, each with varying physical constants and laws, then the apparent fine-tuning of our cosmos becomes less miraculous, yet also less comforting. We may inhabit a universe hospitable to life merely by chance, a statistical inevitability among countless possibilities. But if the multiverse exists, it is largely inaccessible. Its other realms lie beyond observation, beyond measurement, beyond confirmation. The paradox is psychological as well as scientific. Reality may extend infinitely, yet our comprehension is bound by what we can perceive. Cosmologists lie awake grappling with questions that may never have answers, aware that the ultimate nature of existence might forever elude human understanding. Black holes add another layer of unease. Within these cosmic singularities, matter collapses to infinite density, space-time folds, and time itself may cease to exist. They are laboratories of paradox. The very laws of physics break down at their cores. General relativity predicts singularities, while quantum mechanics refuses to allow infinities. Reconciling the two is one of modern physics' greatest challenges. The paradox of black holes extends further. Their event horizons hide information, raising questions about whether information is destroyed, preserved, or transformed, a dilemma known as the black hole information paradox. Even these violent, silent regions of space hold mysteries that resonate with cosmologists' deepest unease, a reminder that reality itself contains contradictions at every scale. Cosmic horizons further complicate understanding. The finite speed of light and the universe's age limit observation to a portion of the cosmos, leaving regions forever hidden. Events beyond this horizon occur in isolation, evolving independently, yet they exist, perhaps affecting the broader universe in ways we cannot detect. The observable universe is thus a patchwork, a fragment of the whole, and every conclusion we draw is necessarily provisional. Cosmologists lie awake contemplating what lies beyond, realizing that the greater reality is likely far more complex, stranger, and unknowable than we can imagine. Yet, paradox is not merely a source of anxiety, it is a source of awe. In the tension between certainty and uncertainty, order and randomness, the finite and the infinite, lies the beauty of the cosmos. Cosmologists, philosophers, and curious minds alike are drawn to these questions because they touch the deepest aspects of existence. The universe challenges us, teases us, and rewards our curiosity with glimpses of profound truth. Even the fact that we can formulate these paradoxes, model cosmic evolution, and probe the unknown is a testament to the human capacity for wonder. If this tension between knowledge and mystery captivates you, then 404 Altverse is where you belong. Subscribe and join us as we venture into the paradoxes that define reality, exploring the edges of comprehension, the unknown, and the awe-inspiring. Each episode, each exploration, is a journey into the cosmic questions that keep minds awake, hearts racing, and imaginations alight. The paradoxes are also intimately connected to existence itself. The universe may be infinite, yet life is finite. The cosmos may be deterministic in one sense, yet probabilistic in another. Time may flow, yet entropy rises. Consciousness emerges, yet understanding remains incomplete. Every human endeavor, every observation, every calculation is part of a dialogue with the universe's enigmas. Cosmologists are awake not because the answers are frightening, but because the questions are endlessly compelling, revealing layers of reality that stretch beyond the observable, beyond the calculable, and beyond the imaginable. Ultimately, the paradox reminds us of humility and wonder. It is a mirror reflecting both the grandeur of the cosmos and the limits of human perception. It is an invitation to curiosity, a challenge to imagination, and a meditation on existence itself. The universe is stranger, more elegant, and more profound than any model can capture. It is a puzzle, a mystery, and a canvas upon which the forces of reality are written, yet much of it remains obscured, waiting for minds brave enough to explore the unknown. As we confront these cosmic contradictions, we are reminded that paradox is not failure. It is the signal that understanding is evolving, that discovery continues, and that the universe is alive with questions that may never be fully answered. In embracing the paradox, cosmologists and dreamers alike touch the infinite, wrestle with the unfathomable, and glimpse the sublime. The universe keeps its secrets not out of malice, but because it is vast, complex, and magnificent beyond comprehension. To lie awake pondering its deepest mysteries is not folly. It is participation in the greatest exploration of all, the quest to understand existence itself. And in that quest, we find wonder, humility, and the courage to confront the unknown.